Greece have declared a state of emergency after several days of consecutive earthquakes on the island of Santorini.
The ground beneath the Aegean Sea is speaking, and for the first time, scientists finally understand what it is saying. In late January of 2025, the island of Santorini began to tremble. Not once, not twice, but thousands upon thousands of times. A relentless, rolling cascade of earthquakes that would not stop for weeks. By the time the shaking began to ease, more than 28,000 seismic events had been recorded beneath one of the most visited islands on Earth. Schools closed. A state of emergency was declared. Tourists fled by ferry in the middle of the night. And deep beneath the sea floor, something enormous was moving. But here is what no one knew yet. This was not just Santorini's problem. What scientists discovered in the months that followed would rewrite the volcanic map of the Aegean. Because the earthquakes were not random. They were not even primarily tectonic. They were the footprints of 300 million cubic meters of molten rock, the equivalent of 200,000 Olympic swimming pools, forcing its way through the Earth's crust in pulses, fracturing stone, opening channels, and migrating more than 10 kilometers to the northeast. And as researchers traced that magma's path, they found something that had been suspected but never confirmed. Santorini and Kolumbo, two of the most dangerous volcanoes in the Mediterranean, are not separate systems. They share a single, connected underground reservoir, one heartbeat, one network, one fate. That discovery changes everything. It began quietly, as these things often do. As early as July of 2024, instruments detected something subtle but significant. The island of Santorini was lifting, just a few centimeters, barely measurable by anything other than the precise GPS stations that stud the Aegean like scientific sentinels. But ground uplift at a volcano is never meaningless. It means magma is accumulating somewhere beneath. Pressure is building. The crust is bending upward under the weight of something rising from below. For months, the signals remained modest. There was a smaller swarm in 2024, enough to register, but not enough to alarm. Santorini is a volcanic island. It shakes periodically. Scientists monitored the data and waited. Then, on the evening of January 27, 2025, at 1900 hours Coordinated Universal Time, the system crossed a threshold. Magma that had been accumulating in a shallow reservoir began to move in earnest. According to studies published in the journals Nature and Science, seismicity exploded almost instantly. In the first 5 days alone, the pattern was extraordinary. Earthquakes initially propagating toward Santorini's center, then pivoting and migrating rapidly to the northeast, away from the island and toward open water. The crust was fracturing not from tectonic stress, but from something pushing through it. The National Observatory of Athens activated full emergency protocols. Within days, Greek Civil Protection was issuing public advisories. At least 12 additional seismic monitoring stations were deployed across the region. Underwater sensors were placed near Kolumbo. The European Union's Copernicus satellite system was activated to track ground deformation from orbit. And an artificial intelligence model, newly developed for real-time earthquake localization, began sorting through the torrent of incoming data, locating hundreds of events per day with a precision that would have been impossible just a decade earlier. By the peak of the crisis in early February 2025, instruments were recording thousands of seismic events every single day. The largest individual earthquake reached a magnitude of 5.3. On February 20th, 2026, more than a year after the swarm began, a magnitude 4.1 earthquake struck at 11:45 Coordinated Universal Time, a reminder that the system had not gone silent. But that is only part of the story. To understand what was actually happening beneath Santorini in 2025, you have to understand the mechanics of a magma intrusion, and why what scientists documented here is so scientifically extraordinary. Magma does not move through the earth in a smooth, steady flow. It does not behave like water running through a pipe. It moves in pulses, it smashes through rock, opens fractures, forces cracks wider, and then when the pressure temporarily equalizes, it pauses, sometimes for hours, sometimes for days, before the next surge of pressure drives it forward again. Each pulse fractures more rock. Each fracture triggers more earthquakes. And the pattern of those earthquakes, their depth, their distribution, their timing, acts as a kind of X-ray. a moving image of where the magma is going and what it is doing. Researchers led by Dr. Anthony Lomax used this principle to reconstruct the entire journey of the 2025 intrusion. What they found was staggering. Approximately 300 million cubic meters of molten rock moved through the crust along a channel stretching 30 kilometers horizontally, more than 10 kilometers beneath the seafloor. The magma did not rise toward the surface. Instead, it moved laterally, sideways through the crust, following pathways of least resistance, opening what geologists call dikes. Thin vertical sheets of rock cracked apart and injected with magma across a horizontal area spanning 20 kilometers. The stress patterns recorded by seismometers matched exactly what you would expect from magma forcing open cracks, not from the kind of horizontal fault slip that characterizes a tectonic earthquake. The fracturing was volcanic in origin, and critically, the magma settled at a final depth of approximately 4,000 meters below the ocean floor. At its shallowest point during the intrusion, it reached approximately 3 kilometers below the seafloor, never close to erupting. It lacked the pressure and buoyancy to punch through the remaining kilometers of cold, dense ocean crust above it. Eventually, cut off from additional supply, it cooled. It solidified. The crisis ended, not with a volcanic eruption, but with the Earth quietly sealing itself. And yet, what the crisis revealed may matter more than any eruption. Before 2025, the relationship between Santorini and Kolumbo was theoretical. Kolumbo is an underwater volcano located 7 kilometers northeast of Santorini. Invisible to most tourists, sitting silently beneath the Aegean, but far from dormant. It last erupted in 1650 with a highly explosive event that killed dozens of people. Its crater rises to within 18 meters of the ocean surface. Tsunami risk from a Kolumbo eruption has been modeled in scientific literature for years, but the question of whether its magma system was truly connected to Santorini's, whether what happened under one could directly influence the other, remained open. The 2025 swarm answered that question with clarity. The nature study confirmed it. Santorini and Kolumbo are fed by a shared coupled magma system. The magma that moved in 2025 originated from deeper reservoirs beneath both volcanoes, migrating horizontally through a shared underground channel at significant depths beneath the seafloor. When magma moves in one part of that system, it changes pressure throughout the entire network. Two volcanoes, 7 kilometers apart, acting not as neighbors, but as partners. Yet, what comes next could be even more significant. To understand what a coupled volcanic system truly means, history offers a sobering mirror. In 1650, Kolumbo erupted on its own, with consequences that extended well beyond the island of Santorini. The explosion generated toxic gas emissions and a tsunami. Dozens of people died. The eruption was brief but violent, and it was driven by the same regional magma system now confirmed to connect both volcanoes. Go back further, far further, and the picture becomes almost incomprehensible. Around 1620 BCE, Santorini experienced one of the most powerful volcanic eruptions in human history. The Minoan eruption, named for the Bronze Age civilization, whose network of Mediterranean trade and culture may have been severely disrupted by the event, ejected an estimated 28 to 41 cubic kilometers of volcanic material in dense rock equivalent terms. The caldera that defines Santorini's famous crescent shape today is the scar left behind. The sea rushed in to fill the void. The island as it existed before was gone, replaced by the submerged bowl that now forms one of the most photographed bays on Earth. No one alive today has witnessed anything remotely like it. But the Earth that produced the Minoan eruption is still there, still active, still generating the pressure and heat that drove 300 million cubic meters of magma through the crust in 2025. The system did not exhaust itself. It rested. Between the Minoan eruption and today, Santorini has erupted repeatedly. In 726 in 1866 through 1870, again in 1925 through 1928, 1939 through 1941, and last definitively in 1950 on the intracaldera island of Nea Kameni, producing a lava dome. Those eruptions were modest compared to the Minoan event, effusive, dome-building, weak to moderate in explosivity. They killed no one. They reshaped no civilizations. But they confirm that this system has never stopped. Then on July 9th of 1956, the Aegean delivered a different kind of violence, two powerful tectonic earthquakes, magnitudes 7.4 and 7.2, struck 13 minutes apart, generating a tsunami that swept across the southern Aegean. Communities on multiple islands were damaged. Dozens were killed. The event still shapes local memory and emergency preparedness planning in the region today. It is the earthquake that residents invoked in fear when the 2025 swarm began, because the Aegean has proven more than once that it is capable of catastrophic surprises. And now, scientists fear history may be repeating itself, not in the sense of an imminent eruption, but in the sense of an awakening system. Because the 2025 swarm was not Santorini's first in recent memory. In 2011 through 2012, elevated seismic activity struck the island over several months. Ground deformation was measured, gas emissions increased, and then nothing. No eruption followed. The system returned to rest. That precedent is both reassuring and unsettling, depending on which scientist you ask. Reassuring because unrest does not equal eruption. Because magma can move, pressurize, fracture crust, and still never reach the surface. Because the 2025 intrusion specifically, with magma remaining kilometers below the seafloor throughout, suggests the system was venting accumulated stress without building toward an eruption. Because what comes next could be nothing for years or even decades. Unsettling because the 2025 swarm was significantly larger than the 2011 event. Because for the first time, researchers have confirmed that Santorini and Kolumbo operate as a single coupled system, meaning future instability could trigger responses across both volcanoes simultaneously. Because the magma that cooled and solidified in 2025 did not disappear. It added to the accumulated volume of intrusive rock threading through the crust beneath the Aegean. Each intrusion that doesn't erupt still leaves behind heat, fractures, and altered stress fields that the next intrusion will encounter. Because what happens next could rewrite maps. As of February 2026, the numbers tell a story of partial calm. Seismic event rates have dropped. Tourism has resumed. Booking platforms show steady interest in accommodations for the upcoming season. The roughly 15,000 permanent residents of Santorini have returned to their routines. The ferry lines run normally. The caldera glints in the winter sun, serene as a postcard. But the monitoring continues without pause. The National Observatory of Athens still records seismic events in the region every day. GPS stations still measure millimeter-scale ground deformation, slight subsidence in some areas, continued minor uplift in others. Gas emission sensors remain active. Underwater instruments near Kolumbo continue transmitting. Scientists are watching two volcanoes now, not one. They are watching a system, what they are looking for. What would signal a genuine escalation toward eruption is specific. According to historical records and the knowledge gathered from the 2025 swarm, an eruption would likely be preceded by days to weeks of precursory signals. Renewed uplift, shallow seismicity directly beneath one of the volcanic vents rather than offset from them as in 2025, possible discoloration of the sea surface caused by hydrothermal activity or gas release from Kolumbo, and accelerating ground deformation. None of those signals are present today, but they were absent in the months before July 2024 as well, until they were not. The deeper uncertainty is not about this week or this month. It is about what the coupled system means over the longer arc of time. If future magma input reaches the shared reservoir beneath Santorini and Kolumbo, it will not be entering a cold, undisturbed system. It will be entering one that has been freshly fractured, dynamically stressed, and mapped in extraordinary detail. Scientists now know more about how this system moves, where it stores energy, and what it does under pressure than any previous generation of researchers. That knowledge is genuinely valuable. It could provide critical warning time if the system begins moving again, but knowledge of how a system behaves is not the same as control over it. And in the Mediterranean, where volcanoes have been burying civilizations and reshaping coastlines for millennia, the Santorini-Kolumbo system remains one of the most consequential pieces of unresolved geology on the planet. The magma is still there, cooled for now, but present. The fractures it opened still thread through the crust. The pressure that drove 300 million cubic meters of rock through the Earth in 2025 has not ceased to exist. It has redistributed. It is waiting for the conditions that will allow it to move again. When that happens, and geologists do not say if, the scientists watching will have better tools, better models, and a confirmed map of the system's hidden connections. What they will not have is certainty about which of those connections activates first, or how quickly, or whether the next intrusion stays deep like the last one, or finds a path that the last one could not. The Earth beneath Santorini is not silent, it is thinking. Stay safe, stay curious, and keep your eyes on the Earth.